For this channel we can write our area is perimeter is B plus 2yn so these two that so what will be our hydraulic radius? A by P will be B plus my into y by B plus 2y plus 6. Now we can see our cross-sectional area, our perimeter. Our perimeter and our hydraulic radius. Now for the most efficient cross-sectional trapezoidal channel, it must have a condition where I can insert a semicircle, something like this. That is our geometrical approach. Now in the mathematical or physical case, when the most efficient channel occurs, then the perimeter will be minimum for a given discharge. Then the perimeter, if it is minimum, then we can write the dP by dy 0. Then we can find, in order to solve it, the maxima or the minima of the perimeter. Now dP by dy, if we do that, now we can't put that B into here, so we will transfer the value of B now. The A will be now find the value of B with respect to y and A, then put it here as the B is constant. Now the value of B will be A by y minus my. So E equal to A by y minus my plus 2y 1 plus m square. Okay. Now the dP by dy, if we do that, then what we get? Ay square minus m minus 2 into That all we get. The value will be equal to 0. Now the a y square will be equal to so this thing, this YE, this becomes the efficient depth for the efficient section, and this becomes the efficient area. Now our area is done. Now when our area is done, what our what is our B? If we get our area, then what is our B? It is the value of this. Then you can put the value of B as YE into 2m square plus 1 minus m so what you can see, the value of B will be minus 2. So value of B will be so we have the value of B and value of A. So after having the value of efficient area and efficient width, we can find the value of this P. P is equal to 2y B plus 2y root over m square plus 1. This is our value of the weighted perimeter. Now we do have the value of B. The value of B is 2ye m square plus 1 minus m plus m square equal to 2ye 2m square plus 1 minus m. And so the effective hydraulic radius or R will be A by P. So we have the value of A is, go to the last slide. As you can see from the last slide, the value of efficient area is y square into 2 m square 2 root over m square plus 1 minus m. Then it will be y square 2 into root over m square plus 1 minus m by 2ye into 2m square plus 1 minus m. Cancel out these two, then ye by 2. So the R, the hydraulic radius, the efficient channel section, the hydraulic radius will be equal to this value for a trapezoidal channel. And also for a rectangular channel, the value will be, the rectangular channel, the value of width will be 2y, and the value of the area will be 2y square, and the perimeter will be 4y for an efficient rectangular channel. So now till now what we have done, now we have formulated the trapezoidal channel, efficient trapezoidal channel, where we have considered the side slope is fixed. Now for a efficient trapezoidal channel, the value of the side slope will vary. The side slope, this m or cot theta will vary. Okay, so how it will vary? As you can see, for the side slope it will have such a value that this term, the dp by dm, which is the perimeter, will be equal to 0. Okay, so what is our perimeter again? What is our perimeter? Our perimeter was 2EY 2m square plus 1 minus m. This is our perimeter. So derivative this thing, what we will have? Now the value of this thing, the 2EY, YE, that can't ever be 0, but that thing can be 0. If this thing is 0, then we can write what? 1 equal to 2m by root over m square plus 1 3 3m square equal to 1, m equal to 1 by root over 3. Then this theta m equal to cot theta, you can see. So the theta or the angle of the side slope for efficient channel will be 60 degree for trapezoidal channel. Okay. Then comes our next class of GVF. What is a GVF? GVF is a gradually varied flow. If in constant discharge, the value of this flow profile decrease at a really low rate of time, gradually, or the flow profile changes, or the dy dt changes, then this is called the gradually varied flow profile. Now, when there is a slope which is a critical slope, I mean the YC, the critical depth for a minimum specific energy will be equal to Yn. This is called a critical slope. Then comes the mild slope. A mild slope, what is a mild slope? A mild slope is where the normal depth of flow is greater than the critical depth, called mild slope, and then comes the steep slope where the critical flow depth is bigger than the normal flow. Now, these are some slope issues by which the gradually varied flow can occur. But in order to understand that mathematically, we need to have a flow profile of an open channel, something like this. We have done this in our previous